Okay, so welcome again. What will happen in this chapter, or what we will discuss in the first slide, is the wireless principle, and the first thing will be, like every time I lose my pen, let's examine it. It's working. Okay. The first thing to talk about is that what happens in the wireless worlds, and what happens is some magnetic field will be generated in the air to encode data, and by data we mean the zeros and ones. What happened before, all what happened before in the wired networks, in the cables, in the wires of the wired networks, which whether they were like a copper cables, the Ethernet, the copper cables, or the fiber optic cables. In all of the cases, what happens that what passes through the cables are zeros and ones only. And that is the same thing that will be encoded, transmitted in the air in the wireless networks. Only zeros and ones, just like the same. It's only like replacing the wire with a non-wire, and this non-wire is some frequency sent. And to be more detailed, or to dive even more more deeply in those wireless things that we cannot see right now at all. I have no idea. Okay, there is a router in my room and it's sending to my laptop, mobile phone, PlayStation, etc., but I can see nothing. Okay, but if there was a wire, then I can see that, okay, this wire is going to my laptop, this wire is going to my PlayStation or my smart TV, or any other solution that requires internet but not my mobile phone at all. That's sure. But the point of that is that in wireless networks you have no idea who's connected, and you have no idea who is this router serving, because it's invisible. And what's happening in that invisible thing, in that air that we are breathing, other things are flying here, are the electromagnetic field that's been generating. And this electromagnetic field, what it does is that from point A to point B, and we will talk in minutes about what exactly are point A and B, what's happening is that some frequencies, no, this is not frequency at all. Some frequencies are sent in this way from point A to point B. This change in the frequency, you can see now I have a frequency that is flying in a low range of change, like from this point to this point. We can consider this one as a 0, and this higher frequency, or the big change that happening between going up and down right now, is 1. And then again it goes smaller, this is another 0, and there is again it goes higher, this is another 1. So before, in the previous world, in the previous chapters, in the wired networks, what was happening, like in a copper cable, also there was like an electronic circuit, not an electromagnetic field, but an an electric circuit field. And that electric circuit field used to send like also frequencies. I've talked about this in chapter 1, indicating the ones and the zeros, and the ones and the zeros, etc. But how were they sent, those 1 and zeros? How that field was changing? It was by sending some electro beats or electro signals through this cable. So there was a cable and there was some electricity passing through. There was a fiber cable and there was some light or laser passing through. Right now it's air, it's nothing. So what's happening from point A, point B, there are data going, but I can see nothing. I can touch nothing physically. There is no light that's being sent. There is no electric signals that being sent from point A to B that I can touch them and get shocked, like maybe nothing. Okay, so there is a wireless thing that we will deep dive into and see, and to know what's exactly happening. But basically, an electromagnetic field is being generated to encode from point A some zeros and ones, and when the point B receives those zeros and ones in an electromagnetic shape, it will decode them to translate them back to the zeros and ones, because point B will receive some high frequency, low frequency, high frequency, low frequency, which are ones and zeros. So when it receives it, when point B receives those high and low frequencies or channels, it will decode them to zeros and ones after point A had encoded the ones and zeros to become wireless. So encoding will be done by changing the frequency of a wave. So these are the waves that are happening. There is a low frequency wave for zeros, high frequency wave for ones. Okay, that is measured by hertz, and hertz is the change in frequency per second. So like let's make it a bit more detailed. So it was happening this way more, and the big place, and more like this way, etc. What we mean is that if we took all of this section and divided it per seconds, like we will make this one is second, 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 second in this way, okay, this way, and let's make it this way. So each part of those is 1 second of a time. So a hertz is the amount of how many times did this wave flaps or change during 1 second. You can see starting from this second to this one, it was going up the wave and then it went down. So this is only one change. So what happened during this second is 1 hertz. So this section represents 1 hertz. One change for happened to a wave in a matter of or during 1 second. Okay, but in this second here, you can see from this point to this point, watch out, there is like going up, down, up, down, up, down, 6 changes. Okay, so this one is measured by 6 hertz this way. Okay, so this is the hertz. This is what we mean by hertz. Just don't worry or get confused. In chapter 6 in this new CCNA, you need to know what's happening and how it's done, but you will not modify those basics, and you will not configure higher things or complicated things, and you will not really have this big of deep dive of designing or implementation or optimizing. Those all are for the CCNP. Besides, there is a new certificate called CCIE wireless, and I'm sorry, wireless infrastructure. Yes, alongside with the enterprise infrastructure. So it's replacing the CCIE wireless, the old one. But there is a long way or for these wireless networks, and you have to travel it like from the A up to the E up to the export. So in the CCNA you will not like don't be worried. Yes, there is a lot of information, but all of them are funny and educating and entertainment to know. So that's it. Don't worry about what's happening inside those and how you should change it. No, this is not for you. This is for another transmission or wireless engineers. So I'm sorry. This is, yeah, like right now we are in the time of the corona. This world suffers. Okay, so this cough has nothing to I hope. Anyway, so modulation will express the zeros and ones. What are you talking about? What's modulation? This is a new term that you have just jumped to and you have just mentioned without any startings or openings. Modulation is something I have talked about like 2 times in the past 5 minutes. And what I mean by modulation is changing the behavior of a wave in 1 second to encode more data. Because you can see in this 1 second, only one flap or one change to the wave happened. And this can be like 1 or a 0. That's it. But in this second, 6 changes have been done, and those 6 changes can be all of them like ones, 6 ones, or 6 zeros. You can see, so I have encoded more data in 1 second, and in the other second there was only like 1 bit have been transmitted or encoded in 1 second. So modulation is changing this frequency or this wave change to encode more data. This is a high modulation in here, and this is a low modulation here in this second. So increasing this modulation will make the wave like flaps a lot more times in the same second, and this will cause to encode more data, more zeros and more ones in the same wave, in the same frequency at the same time, so more data will be transmitted. Okay, so there are Wi-Fi generations. This is a note, just it's not related to this one, but these are just some notes that I have written below, because until now I'm like comparing the cables and the wireless field. What's happening in the wireless field? In the wireless cables, there was frequencies but they were transmitted or they were expressed using like electro signals or light signals, changing electro signals or changing light signals. In the wireless field, there is some electromagnetic and there is modulation, and this modulation will change the behavior of a wave or a frequency so that it will express the ones and zeros. Like cables before, Ethernet cables had, or the copper cables had generations like category 1, cat 1, 2, 3, 4, 5, and cat 6, which carries uh, alongside with cat 5e carries 1000 megabit per second. There is some Wi-Fi generations, just like the Ethernet categories. Those generations have a code like cat 1, cat 2. Here we have 802.11 something. 802.11a is the first generation, which carries 2 megabit per second for each frequency that was sent from point A to point B, while the latest generation that will be released or should have been released right now in 2020 is called the 802.ax, the 802.11ax, which carries 14 gigabit per second wirelessly. uh, will I really get 14 gigabit per second wirelessly? Yeah, you wish, because there is moisture, there is heat, there is distance, there is noise, there is other frequencies or other channels in the air that are using the same frequencies and modulation that I'm using, or they are very close to them, so they will interrupt my signal and they will change a lot. And there are much more other physical things that I will talk about in the upcoming slides. All of them will make you will never see a 14 gigabit per second, almost never see a 14 gigabit per second in real life in the wireless networks, but this is their capacity. Okay, this is something that happens. So this is the disadvantage of using wireless networks, is that when you use like a fiber optic that can carry 1 gigabit per second, that's it, it's a 1 gigabit per second. When you use a fiber optic that can, or some SFPs that can carry, I'm sorry, 10 gigabit per second, it's a 10 gigabit per second. A QSFP with 40 gigabit per second, it's a 40 gigabit per second or even 100 gigabit per second, up with the technology that you are using. In wireless, they tell you that it's a 14 gigabit per second. Okay, if you got 10, you are lucky, or maybe 11. This is because of things, but in the end, there is no wires, there is no extending, there is no cables, no etc. There's nothing you should do. Oh, point A is here, point B is like meters or feet away, and it will work. So this is the advantage of the wireless. Okay, so in the upcoming slide, there is a bit more details that we should talk about, and those details will be the encoder, the thing that this device, this facility that is encoding zeros and ones to become an electromagnetic field or a wave in the air. And in the other side, there is a decoder that will receive this electromagnetic field, those waves, and will decode them again to the zeros and ones. Okay, so this encoder, the one who turns zeros and ones to that electromagnetic field, is called a transmitter, and at the same time on the other side it will be called a receiver. So let's call it a transceiver, and it's called transceiver. You will never see it in another name. It's called a transceiver because it's from point A, it's taking all the zeros and ones in a cable, and it's encoding them to become wireless electromagnetic field in the air. So it's transmitting them TX to this side, which is receiving them an RX on the other side on point B, and there will be the same component, the same transceiver on this side is the same one exactly on this other side that will receive this electromagnetic field and will turn it to zeros and ones again and send it to the wired network. So also, you can imagine this same device, this same one device, this your mobile device is sending and receiving data. So using the same transceiver, that's it. So it's definitely will be the same identical component, point A and point B, because it will transmit and receive the electromagnetic field or the waves. So it will be called a transceiver. The more transceivers available inside one device, inside one access point, one wireless controller, one mobile phone, etc., the more data that can be encoded. This is one of the other things that will decrease the capacity of wireless networks, because 802.11ax supports up to maximum of 14 gigabit per second to be transmitted, but this requires, I don't know how many, maybe more than 8 or 10 transceivers inside your device, inside your laptop, mobile phone, antenna, access point, or any other wireless device. So just in case your device does support 802.11ax, which should carry 14 gigabit per second, but at the same time it has only 2 transceivers inside it, you will see only 1 or 2 or even 4 gigabit per second. That's it. Okay, you can see that. Only so the transceivers, the amount of transceivers inside your device do controls the maximum capacity to be of, the electromagnetic field or the data that can be transmitted and received at the same time. And then this transceiver, after it turns the zeros and ones to electromagnetic field or waves, it will push this electromagnetic field through what's called an antenna. Most of you have seen an antenna before. This aero thing, this antenna that is connected to our old devices. We used to buy an antenna before, and this antenna had like short Ethernet cable or a copper cable, and connect the antenna to my desktop computer, the old desktop computers, and then my desktop computer will be able to connect wirelessly to a router in the room or in the office. You remember that? The laptops, most of them, maybe all of them, do comes already with an built-in transceiver and built-in antenna that we do not see, but all desktops needed an external antenna that I should connect using a wire. You can see that. No, we cannot we cannot leave wires at all. That should be used, this small antenna that was connected using a wire to the desktop computer, so that this desktop computer can transmit and receive data to a wireless device, to a remote device wirelessly. So all what's happening inside a transceiver will be pushed to an antenna. This is the antenna that is sending those data through the air, and there is another antenna, of course, in here that will receive those data and will send them or push those data to this guy, to this transceiver here, and this transceiver will receive all those electromagnetic field and will decode them to take out those ones and zeros that should be expressed out of this electromagnetic field. Also, another important thing, the more antennas, the more data that can be transmitted and encoded. So again, when a new generation comes out of Wi-Fi 6, and Wi-Fi 6 is using a protocol of 802.11ax, and 802.11ax can give you up to 14 gigabit per second of data transmission in the air, you must ensure this: how much transceivers in my device and in the receiving device, how much antennas in my device and the receiving device, the quality and generation, hardware generation and quality of those transceivers and antennas. All of those do affect the speed, the maximum speed that can be transmitted in the wireless world. That's why I tell you that you wish to see a 14 gigabit per second using 802.11ax. Maybe in the upcoming generation in Wi-Fi 7, that maybe in some years it will represent or will give you 25 gigabit per second, and you have just bought a new device that does support 8 the Wi-Fi 7 generation and 25 gigabit per second, but only then, and due to all of those things and disadvantages and restrictions, you will get like 10 or 14 gigabit per second, like in years, not now, not in 2020. Or maybe you have, maybe you work in NASA. I don't know who does use all of those high quality equipments, but generally it's really rare to have like the full capacity or to reach the full capacity of a Wi-Fi generation. Also, again, before we end up this video, to finish this slide and the 6.1 subject, to generate and push data through the air, there must be a power. We cannot question that, because just if you think about it for a few moments, I have this mobile device, my big yellow guy here, my mobile device, and this one, when I'm opening like Cisco.com or YouTube to watch one of my videos in the right now, and it's in my hand, so from nothing, it's generating electromagnetic field, and it's pushing this electromagnetic field like for 15 meters for the router in my house and in my home. So that router can receive it, and that router also is sending an electromagnetic or establishing an electromagnetic field between itself and my mobile phone for a distance of like maybe from 1 up to 20 or 25 meters. It depends on the device, but there is an electromagnetic field that is traveling long distances. How's that being pushed? How are all of those waves are being pushed? This requires a power. This requires a power source to generate all of that electromagnetic field. So every single wireless device in the world needs a power source. This power source can be either an AC adapter, like an access point does, a wireless controller does, and your small home router does. All of them comes with an AC adapter to inject them in the socket, in the electricity socket, or other devices like laptop or mobile phones that uses battery. In both cases, power source will be used. Okay, so it's either to be a battery or an AC adapter. Measuring the power of a frequency is called amplitude. Amplitude is like measuring how much this frequency that's traveling right now in the air, how much power does it consume. Okay, so this is something just to know the identification of an amplitude, not to dive in with. So I believe this slide has been done. Yes, it has been done. This video also has been done. That should be enough for this video. I hope it was clear to you. Just in case it wasn't, please comment down below in this video. This is a new thing. And even if you were like a CCNA student before on the old CCNA exam, and this chapter, you are right, you have no idea what's happening. This is an entire new thing for you, and this is an entire new thing for me. Actually, I have studied like this month, like maybe have spent like 2 weeks of studying chapter 6, the wireless networks, because I have really minimum information regarding wireless networks and the wireless world. But we have to study the new thing when it's coming. We have to know the new thing and how to make use of technology, because in the end it will serve us, it will be beneficial for us. So anything that's not clear, please comment down below in the video section, in the section of this in the comment section below in the video, and I will be glad to even do some further research to answer your questions. And in the upcoming video we will start with a new subject. So thanks for watching again, and goodbye.